So let us try to understand how a steam engine works with the help of this schematic diagram. In the beginning, a boiler creates steam and the steam created is fed into the engine through the inlet valve. This steam chest contains the steam and it is allowed to pass through this port P1 into the cylinder. Since the steam is gushing through this port P1, as a result, this main shaft into the cylinder is pushed downwards. This main shaft is connected to this valve rod in such a way when this piston rod is moved downwards, accordingly the valve rod moves upwards. This causes this valve to go up so that both these openings P1 and P2 are blocked by this sliding valve V. As a result, the steam which has already entered the cylinder is getting trapped and it pushes this piston further down. This particular part of this process is responsible for the work done, as this further down motion pushes this valve rod further up and accordingly this wheel connected to this rod rotates. Since this valve rod moves further upwards, now these openings which were blocked now get opened as the valve takes this particular new position. Clearly we can see that this region is now connected through P1 to the E, and what E stands for exhaust. So whatever that is remaining inside the cylinder is allowed to pass through this exhaust valve and it is rejected to the surroundings. Further, as the pressure decreases into this cylinder, now this piston which was moving downwards is now moved upwards and accordingly the valve rod is now moved downwards. Thus, the cycle is complete as this valve returns back to its initial position. Now in order to have this process going on continuously, we need to provide a continuous flow of steam through this steam inlet, and we need to have sufficient amount of water boiling inside this boiler so that this cyclic process goes on continuously and every time the wheel gets rotated, that is, an external work is produced by this engine. Let us have a look at this thermodynamic process. How does it look theoretically on a PV diagram? As can be seen here, the process starts from point A. We can see that this is an isochoric process from A to B. The pressure increases from a value PA to PB. Then next process is subdivided into three parts: B to C, C to D, and D to E. All these three processes are carried out at constant pressure. The part B to C includes a reversible isobaric heating of water in the boiler. till the boiling point temperature Tc is reached. That is, water gets boiled to its boiling point. Now the temperature is further increased so that the is steam becomes saturated. So the temperature of the steam is now increased beyond 100 degrees Celsius, say 150 or 200 and so on. Now larger is this steam temperature, more efficient is this engine going to be. Similarly, the process D to E is again a similar type of process as that of the previous two. Here, the steam is further heated and the process is called as superheating. So that its temperature rises to a further higher value, say TE. Then in the later part, which is described as E to F, which is the reversible adiabatic expansion. Now note that this is an adiabatic expansion, so it causes a drop in temperature along with a suitable work performed. Further, in the last step, which is reversible isobaric isothermal condensation, denoted by step F to A, which is the sixth process. In this process, the steam gets condensed. It gets converted into water back again, and we can make a suitable arrangement such that it is fed back to this boiler to get heated again and making it available into the steam chest. This cycle can be repeated, and every time work can be extracted from this engine. But we should note that such type of engine is very less efficient. Typically, the theoretical values for such type of steam engines are 8 to 10% thermal efficiency. That is, if we provide with say 100 joule of energy, then almost 90 joules of energy is wasted to the surroundings, and only 10 joule is converted into useful mechanical work. Hence, people have already shifted, so water is abundantly available and this process is very simple. People have shifted from steam engines to other possible engines many years back. The formula for efficiency of this engine is given by the enthalpy, the ratio of differences in enthalpy, that is He minus Hf divided by He minus Ha. So we need to know the values of enthalpies at points E, F and A in order to calculate the efficiency of this engine. Another factor which characterizes the engine is its power. And there again, at least theoretically, the power of this engine is simply given as 2 times PLN plan. So what does this mean? This P indicates the value of pressure created in Newton per meter squared. L indicates the amount of displacement of the piston, that is the distance by which the piston inside this cylinder moves up or down. This factor 2 appears because the piston moves up and down, and during every upward or downward motion it delivers some power. So we have to multiply this L by a factor of 2. Now this A indicates the cross-sectional area of the piston. Cross-sectional area of the piston. So larger is the cross-sectional area of the piston, larger power would be delivered by the engine. And N is the number of cycles per second of this particular up and down motion of the piston. That is, say 200, if the piston moves up and down 200 times in a second, then N value for this engine is just 200. So these are the factors which decide the power of a steam engine. Now we can also modify this formula, because typical values of steam engines power are expressed in kilowatts. If we use SI units here, this gives the power in watt. So if we divide this quantity 2 times plan by 1000, we get the power in kilowatt. Just to have an idea of how much power a steam engine can deliver, let us just put some values for these factors. Suppose pressure for a steam engine is 10⁵ Newton per meter square. So this is quite a quite value comparable with the atmospheric pressure. Now suppose the length of the stroke, that is the upward and downward motion, the distance to which the piston moves, is 1 meter. So which is a very quite large value. The area of the cross section of the piston is say 0.25 meters squared. Is pretty small. And if the engine performs 5 strokes per second, so the piston moves up and down 5 times in 1 second, which is a very small value. So P in that case is going to be just 2 into plan, that is 10⁵ into 1 into 0.25 into 5. And if we need the answer in kilowatt, let us divide it by 1000 as mentioned here. So this just gives us 250 kilowatt. So this is not a big deal of power as it is less than 1 horsepower. Typical motorbikes, which are 100cc or 125cc motorbikes, which are commuter bikes, have 8 to 10 horsepower of engine. So this is almost 32 times larger power. Just imagine a 100cc diesel or a petrol engine of volume only 100cc, that is 100 ml, which is capable of delivering a very large amount of power as compared to this steam engine. This was an example given just for getting a comparison between steam engine and internal combustion engines as petrol and diesel engines. Thank you.